I'm Daniel Antonio Figueiredo. My qualifications are BE Electronics and Telecommunication from COEP Pune and MTech in Electronics Design Technology from CEDTI of India. Today, I'll be taking the subject Linear Integrated Circuits and Systems, LICS as known, and I will be taking the topic Operational Amplifiers. It will be the introduction to Operational Amplifiers. Today, I will begin the subject of Linear Integrated Circuits and Systems, known as LICS. I begin with the topic of Operational Amplifiers. What is an amplifier? Amplifier is a two-port device that accepts an externally applied signal called input and generates a signal called output, such that output is equal to gain into input. Gain is nothing but a suitable proportionality constant. Now, let us see what is a voltage amplifier. Let us see now the figure on the whiteboard. Please see the figure on the whiteboard. Now the source Vs, Rs, source resistance, Ri, internal resistance of the source of the amplifier of the source, and input voltage. Now this is a voltage amplifier. This is the voltage amplifier. There's Ri, open circuit gain, open circuit voltage gain, output resistance, and AOC into Vi, then RL, and output voltage. Now, let us find the expression for V0 in terms of Vs. Applying the voltage divider formula at the output port yields V0 is equal to RL, R0 plus RL, AOC into Vi. AOC is nothing but unloaded or open circuit voltage gain. Applying the voltage divider formula for the input port yields Vi is equal to Ri upon Rs plus Ri into Vs. Hence, V0 is equal to RL upon R0 plus RL, AOC into Ri upon Rs plus Ri into Vs. Hence, V0 upon Vs is equal to Ri upon Rs plus Ri into AOC upon RL upon RO plus RL. Therefore, we see that VO upon Vs is equal to AOC when RL is equal to infinity and RO is equal to 0. Now, Rs and R0 load the input and the output. Now, if the loading is to be eliminated in the voltage amplifier altogether, then we have to have V0 upon Vs equal to AOC. That is, making Ri is equal to infinity and RO is equal to 0. Practically, a designer always tries to achieve that the condition for making Ri is much greater than Rs and RO is much less than RL in the above formula, that is this one. This one. Ri much greater than Rs and RO much less than RL. This is done for all the input sources and output loads that the amplifier is likely to be connected to the operational amplifier. The operational amplifier is a voltage amplifier with high gain. What distinguishes op-amps from all other voltage amplifiers is the size of their gain. For example, 741 op-amp, the typical gain is of 2 lakhs. Gain is expressed in dB. Now, as we see on the whiteboard, op-amp is a voltage amplifier with high gain. For example, 741 op-amp of Fairchild, the gain of is about 2 lakh, which is equal to 20 log of 10 into 2 lakhs. For example, OP77 also has a gain of 12 million, which is equal to 12 log 10 by base 10, 12 into 10 raised to 6, which is equal to 141.6 dB. Now, it is seen from these two examples that higher the gain, the better is the op-amp. Or op-amp should have tendency towards infinite gain. Should have tendency towards infinite gain. Now we'll see the op-amp symbol. and power supply connections, which are as follows: op-amp symbol and power supply connections. Okay. Now this is the op-amp. The arrowhead signifies signal from inputs to the output. The arrowhead signifies signal going from input to the output. This is the arrowhead. Now, op-amp has two supplies, VCC and VE. VCC is this and VE is this. Positive and negative. Positive and negative. It is grounded. It is grounded here. There's positive VCC and minus VE. And this is nothing but V output voltage. This is inverting input, inverting voltage at the input, then inverting input, and this is the non-inverting voltage at the non-inverting input. Op-amp do not have a zero voltage ground terminal. Ground's reference is established by a power supply common as shown in the figure. The supply voltages VCC and VE are about plus minus 15 volts, plus 15 volts and minus 15 volts. Of course, other values are also possible. We must apply power to make op-amp function. We must apply power to make op-amp function. Now next, the equivalent circuit of a power op-amp. This is the op-amp. This is the inverting input at the inverting terminal. This is the non-inverting voltage at the non-inverting terminal. This is RD or differential resistance, and this is R0 output resistance, and this is AVD. AVD is nothing but open loop gain and differential gain. This is the output voltage. For a 741 op-amp, RD is equal to 2 mag, A is equal to 2 lakhs, R0 is equal to 75 ohms. VD is nothing but Vp minus Vn. V0 then is equal to A times or open loop gain times Vp minus Vn. Vp minus Vn. Input port is a double-ended type. Output port is a single-ended type. As I said earlier, Vd is nothing but V0 upon A. Vd is nothing but V0 upon A. This is the ideal op-amp. In an ideal op-amp, Vn, there are no currents that are going to the inputs, Vn or Vp, as said earlier. Rd is equal to infinity, A is equal to infinity, Ro is equal to 0. Ro is nothing but output resistance, A is open loop gain, and Rd is equal to differential input resistance. Vd, as we said, is V0 upon A. Now, as A tends to infinity, Vd becomes V0 upon A or V0 upon infinity, that is equal to 0. How can this be 0? That means it makes you wonder how the amplifier with 0 input can sustain a non-zero output. Shouldn't the output also be 0? The answer is A approaches infinity, Vd approaches 0, but in such a way as to maintain the product AVD non-zero and equal to VO. Now we are saying op-amps. For proper selection of its external components, it could be configured for a variety of operations. Now, hence the name operational amplifier. Now the operations are amplification, addition, subtraction, differentiation, and integration, and maybe logarithmic amplifier, anti-logarithmic amplifier, instrumentation amplifier. The first application of op-amps were in analog computers. The ability to perform mathematical operation was a result of combining high gain with negative feedback. In 1968, Fairchild Semiconductor introduced the first op-amp, the popular MU-A741. Thank you. Thank you for watching my video on linear integrated circuits and systems. If you like my videos, please subscribe to my channel and press the bell to get my new video notification. Thank you.